Hello everyone, I'm Himishri and today I'll be discussing on the topic on how to write a C program to find the roots of quadratic equation. Solving quadratic equations with C programming. Today we will explore the implementation of a C program to find roots of quadratic equations, understanding mathematical concepts and discover real-world applications. Understanding quadratic equations. Definition of a quadratic equation. A quadratic equation is a second-degree polynomial equation characterized by its standard form ax squared plus bx plus c equals 0, where a, b, and c are constants. Standard form ax squared plus bx plus c equals 0 is used to express quadratic equations where a, b, and c are constant, with a being a non-zero to ensure that equations is truly quadratic. Role of constants a, b, and c. In a quadratic equation, a, b, and c are constants that define the curve's shape and position. The non-zero value of a ensures the equation is quadratic and affects the parabola's direction. Importance of being a non-zero. For an equation to be classified as quadratic, the coefficient a must be non-zero. This ensures the presence of the x squared terms, which distinguishes quadratic equations from linear equations. Concept of roots of the quadratic equation. The roots of a quadratic equation are the values of x that satisfy the equation. These roots can be real or complex numbers and are crucial for understanding the equation's solution. Roots in quadratic equations. Applications across multiple domains. Engineering and physics. Quadratic equations are crucial in modeling physics phenomena such as projectile motion, vibrations, and structural engineering calculations. Understanding roots helps in predicting behavior and optimizing designs. Computer science. Roots of quadratic equations are often required in computer science algorithms for optimization and problem solving. They help in improving computational efficiency and accuracy in various applications, from graphics to data analysis. Economics. In economics, quadratic equations assist in determining profit margins and cost functions. By finding roots, economists can analyze break-even points and optimize financial decisions, enhancing economic strategies and outcomes. Understanding quadratic functions. Finding the roots is fundamental to understanding the nature and behavior of quadratic functions. Overview of the quadratic formula. C program structure. Understanding core C program elements. Include libraries. In a C program, libraries are included using the #include directive. They provide the necessary functions and macros for standard operations, such as input-output with stdio.h. Main function. The main function is the starting point of any C program. It is where program execution begins. Essential for defining the logic, it returns an integer value upon completion. Return statement. The return statement in the main function indicates the program's termination. It returns a value to the operating system, typically 0, to signal successful execution. Overview of key variables. Coefficients a, b, and c. In the program, a, b, and c represents the coefficients of a quadratic equation ax squared plus bx plus c equals to 0. These are fundamental to forming the equation and influence the roots. Discriminant. The discriminant is crucial for determining the nature of roots in a quadratic equation. It is calculated as b squared minus 4ac, guiding whether roots are real or complex. Root variables. Root 1, root 2. The variables root 1 and root 2 are used to store the solutions of the quadratic equation. These roots are derived using the quadratic formula and their discriminant value. Temporary variable temp. Temp is utilized for intermediate calculations, often aiding in operations that prepare values for final output or adjustments without altering original data. Input and output in C. Mastering scanf and printf in C. Introduction to I/O and Introduction to input and output in C. Understanding the basics of input and output in C is essential. This slide covers the primary functions used for handling user input and displaying output. Using scanf for input. The scanf function is utilized to read formatted input from the user. In this example, it reads coefficients a, b, and c for processing. Using printf for output. The printf function is employed to display formatted output. It's used to show the calculated roots of a quadratic equation here. Code example. Example code. Printf. Enter coefficients a, b, and c. Scanf. Demonstrates input and output usage in C. Formatting considerations. Proper formatting ensures that input and output are easy to read and understand. It's crucial for maintaining clean and efficient code. Code implementation steps. A guide to calculating growth. Include necessary header files. Start by including the essential header files required for the program. These files provide necessary functions and definitions that your code will utilize. Declare variables. Declare all necessary variables such as coefficients for the quadratic equation. This step organizes the data you will work with in the program. Input coefficients from the user. Prompt the user to enter the coefficients from the quadratic equation. Collect and store these inputs in the previously declared variables for further computation. Calculate discriminant. Compute the discriminant using the formula b square minus 4ac. This value is crucial in determining the nature of the quadratic equation roots. Determine the nature of the roots. Using the discriminant, ascertain whether the roots are real and distinct, real and equal or complex. Output the roots based on the discriminant's value. Use conditional statements to print two real roots, one real root or complex roots. Conditional logic for roots. Implement logic. If discriminant is greater than 0 for two real roots, else if. Discriminant 0 for one real root, else for complex roots. Roots calculation methods. Two real roots. Apply the quadratic formula which is used to find two distinct real roots of a quadratic equation. This method is straightforward and widely used in algebra. One real root. When a quadratic equation has only one real root, it is a repeated root, also known as double root. This occurs when the discriminant is 0. Complex roots. In cases where the discriminant is less than 0, the roots are complex numbers. Here we utilize complex number representation to display these results accurately. Handling complex roots in code. Implement code logic to check the discriminant and handle cases where roots are complex, ensuring proper output for complex roots. Quadratic equation roots. Identify coefficient. The quadratic equation given is 2x squared plus 4x plus 2 equals 0, where the coefficients are 2, 4 and 2. These values are essential for solving the equation using the quadratic formula. Calculate discriminant. The discriminant d is calculated as b squared minus 4ac equals 4. A discriminant of 0 indicates that the equation has single repeated root. Determine the root. Since the determinant is 0, the root is given by x equals minus b by 2a equals minus 4 by 2 cross 2, which equals minus 1. This means the quadratic equation has one repeated root at x equals minus 1. Error avoidance and debugging. Avoid common mistakes and refine your debugging skills. Incorrect coefficients input. Always ensure that coefficients are entered as numerical values. This prevents errors in calculations, especially in software dealing with equations. Division by 0. Before calculations, verify that the divisor, particularly coefficient a, is not 0 to avoid runtime errors that can crash programs. Handling complex roots. When dealing with complex numbers, ensure the use of appropriate data types which can handle real and imaginary components accurately. Debugging with print statements. Use print statements strategically to track and display variable values throughout the execution for easier error locations. Testing different coefficients. Test your program with a variety of coefficients to ensure robustness and accuracy across different code optimization strategies. Avoid repetitive calculations. To enhance code efficiency, avoid repetitive calculations by storing results like the discriminant calculation in variables. This reduces processing time and improves readability. Use functions. Modularize use code using Use functions. Modularize your code using functions to promote clarity and reusability. Functions like calculate roots, improve structure, and make debugging easier. Efficient input handling. Improve input handling by validating user inputs to prevent errors and ensure the program runs smoothly. This enhances user experience and data integrity. Computer graphics, collision detection. In computer graphics, quadratic equations are used in algorithms for collision detection. This ensures realistic interactions between objects and digital environments. Statistics, curve fitting. Quadratic equations assist in curve fitting and regression analysis in statistics, providing models that best represent data trends for prediction and analysis. Importance of calculating roots. Understanding how to calculate roots is crucial across these fields, enabling accurate analysis, prediction, and optimization in various professional contexts. Quadratic equations and programming. Significance of quadratic equations. Quadratic equations are fundamental in fields such as physics, engineering, and finance. They help model various real world phenomena, including projectile motion and economic trends. Importance of the quadratic formula. The quadratic formula is a vital tool for finding the roots of quadratic equations. It ensures solutions can be found even when factoring is complex or impossible. Enhancing programming practices. Adopting proper programming practices enhances code efficiency and readability. This includes writing clean, organized code that is easy to maintain and understand. Validating inputs and error handling. Always validate inputs to ensure data integrity. Implementing error handling prevents crashes and maintains seamless user experience in software applications. Conclusion on quadratic equations. Importance in C programming. Understanding quadratic equations is vital in C programming due to its wide applications in computations and problem solving, which are crucial for both students and professionals. Theoretical foundations. Quadratic equations have a rich mathematical Quadratic equations have a rich mathematical foundation. Grasping these concepts helps in translating theoretical knowledge into efficient coding practices. Practical coding techniques. Implementing quadratic solutions in C sharpens coding skills and problem-solving abilities, making programmers adept at handling complex calculating techniques. Implementing quadratic solutions in C sharpens coding skills and problem-solving abilities. Encouragement to experiment. Experimentation with varied coefficients and quadratic equations fosters creativity and enhances analytical skills. It encourages a deeper understanding of programming logic. So this was it about my presentation on how to write a C program to find the roots of quadratic equations. Thanks for watching.